friends, today we shall discuss a very important mathematical tool which plays a major role in physics as well, such as in chapters like kinematics, and that is differentiation. First, let's understand that what is differentiation and how do we apply it. So differentiation measures the rate of change. Now what is rate of change? Let's understand that. So rate of change is of two types: average rate of change and instantaneous rate of change. Average rate of change refers to a big change and instantaneous rate of change refers to a very small change. Average rate of change is defined for an interval. For example, if we have the interval from x is equals to 1 to x is equals to 10. So we will represent this change as delta x. So to represent average rate of change, the symbol delta is used. So this small triangle which you can see is the delta symbol. Similarly, instantaneous rate of change is defined for a particular instant. So whenever we want to find the change at a particular instant, we have to use instantaneous rate of change. So the change at x is equals to 2 will be represented as dx, and d symbol is used for instantaneous rate of change. Now, average rate of change of y with respect to x will be written as delta y upon delta x. So whenever we are writing delta y upon delta x, it means that average rate of change of y with respect to x. And similarly, instantaneous rate of change of y with respect to x can be written as dy upon dx. So for average rate of change, delta symbol is used. For instantaneous rate of change, d symbol is used. Hence, whenever we see dy upon dx, it means the instantaneous rate of change of y with respect to x. So here you can see that in dy upon dx, how we will solve it? We have to use differentiation. So to find the value of dy upon dx, we will have to differentiate y with respect to x. So let's see the major laws of differentiation. So let's study the rules of differentiation. So the first rule says that if y is equals to constant, then dy upon dx will be equal to 0. So if y is constant, then differentiation of y with respect to x will be 0. So let's take few examples. So let's take that y is equal to 5. So as 5 is a constant, so value of dy upon dx will be 0. So if y is any constant, let's take y to be minus 1, y is equals to minus 1, then again the value of dy upon dx will be 0. So if y is any constant, then value of dy upon dx is 0. Now let's understand the second rule. The second rule says that if y is equals to x to the power n, then dy upon dx will be equal to nx to the power n minus 1. Let's understand this with the help of few examples. So the first example is that y is equals to x square, and now we have to find dy upon dx. So here, what is the value of n? What is the power? That is 2. So here n is equals to 2. Now we will apply the rule and bring this 2 forward. So now in the power it will become n minus 1, that is 2 minus 1. So this will become 2x to the power 1. Now we know that 2x to the power 1 can also be written as 2x. So in this, what we did that we brought this power forward, and in the power we subtracted 1 from it. So it became 2x to the power 1. Now let's take another example. This time we are given y is equals to root x. So now what we will do? For this, what we will do is that we can write y is equals to root x as y is equals to x to the power half, because square root of anything means that it is raised to the power half. Now we have to find dy upon dx of x to the power half, and we will apply the same rule again. This time the n will be half, so we will bring this half in front, and in the power we will subtract 1 from it. So this will become half x to the power half minus 1. Now when we will solve this, we will get it as half x to the power minus half. So dy upon dx will be equal to half x to the power minus half. So I hope that this rule 2 is clear. Now let's discuss the third rule. This rule is quite related to the second rule which we have read before. So that's why I will directly explain it with the help of an example. So consider that in the question we are asked that y is equals to 5x cube and we have to find dy upon dx. So we know that what will be the differentiation of x cube. But what we have to do with 5? Let's see that. So what we will do that whenever we are given a question in which there is some power of x as well as a constant, then in that we will not touch the constant. So directly we will write the constant as 5 and we will differentiate the power of x. So we will write 5 into dx cube upon dx. So now we can easily do the differentiation of x cube using the second rule. So this will become 5 into 3x 3 minus 1. So this will become 5 into 3x square. So when we will multiply this will become 15x square. So differentiation of 5x cube will become 15x square. Now we have another example. This time we are given 6x, that y is equals to 6x. So again we will apply the same rule. So dy upon dx will become, we will not touch the constant will remain same, 6 into, we will differentiate the x. So this will become, because 6x can be written as x to the power 1. So this 1 will be put in the front and in the power we will subtract 1 from it. So it will become 6 into 1 x to the power 0. Now anything to the power 0 is 1. So that's why this will become 6 into 1, that is 6. So differentiation of 6x will be 6. Now let's discuss the fourth rule. In the fourth rule, that it is related to addition and subtraction. So what we will do when we are given addition and subtraction in the function. So if y is equals to 3x cube plus 2x square minus 5. Now how will we solve this? So dy upon dx will become, what we have to do is that we have to simply differentiate all these three terms separately and put the operator in between. So differentiation of 3x cube will be 3 into, as n is 3, so this 3 will become forward, square, plus 2 into, as n is equals to 2, this will become forward, 1, minus, differentiation of constant is 0, so minus 0. So now we just have to solve this. So this will become 9x square plus 4x. So this will be our answer. Now the fifth rule is that if y is equals to a to the power x, in which a is a constant, then dy upon dx will be equal to a to the power x log a. For example, y is equals to 4 to the power x. So dy upon dx will be equal to 4 to the power x log 4. Now, in the sixth rule, we are given that y is equals to log x. So y is equals to ln x. So what will be the differentiation? So dy upon dx will be equal to 1 upon x. Similarly, in seventh rule, if y is equals to e to the power x, then dy upon dx will be equal to e to the power x. So no change will take place in the seventh rule. So these are some basic rules which you have to remember. Now let's discuss the rules related to trigonometry. So the eighth rule is that if y is equals to sin x, then dy upon dx is equals to cos x. In ninth rule, if y is equals to cos x, then dy upon dx will be equal to minus sin x. Similarly, if y is equals to tan x, then dy upon dx will be equal to sec square x. Similarly, if y is equals to sec x, then dy upon dx will be equal to sec x tan x. And the 12th rule is that if y is equals to cot x, then dy upon dx will be equal to minus cos x square x. So the 8th and 9th rules that were related to sin x and cos x are very important. And the 10th, 11th and 12th rules, they are slightly lesser important. But if you want to remember them, then you can do that. Now let's discuss the rule number 13. So this rule is also called product rule. So in this product rule, if you are given that y is equals to y1 into y2. So this y1 and y2 are any two numbers. And we are given that y is a function of y1 and y2. Now how will we find dy upon dx? So dy upon dx, what we have to do is that first you have to take the first number y1 and we have to differentiate the second number. So dy2 upon dx plus take the second number y2 and differentiate the first dy1 upon dx. So basically first take the first number, differentiate the second, multiply the both, put a plus sign, take the second, differentiate the first and multiply them both. Now let's understand this with the help of an example. So let's take that we have to find y is equals to x square into sin x and we have to find dy upon dx. So just we will apply the product. First we will take the first number x square and differentiate the second. So differentiation of sin x is cos x plus take the second number sin x and differentiate the first. So differentiation of x square will become 2x by applying the rule number 2. So now we just have to simplify this. So this will become cos x square plus 2x sin x. So this will be our answer. Now the 14th rule is division rule. In this, if you are given that y is equals to y1 upon y2 and now we have to find a differentiation. So dy upon dx will be equal to, first we will take the denominator y2 and differentiate the numerator. So dy1 upon dx. And now in multiplication we had put plus sign, in division we will put minus sign. And take the first number, differentiate the second number. dy2 upon dx. So in multiplication rule, we first took the first number and differentiated the second number. But in division rule, first we will take the second number and differentiate the first number. Because if we do otherwise, then when we will do subtraction, then the answer might change. And in the denominator, we will put y2 whole square. So this is a division rule. y2 differentiation of first number minus y1 differentiation of second number upon y2 square. So let's solve the question based on division rule. So in this question we are given y is equals to x square plus 1 upon x cube, and we have to find dy upon dx. So the first step would be that we will take the second number, that is x cube, the number in denominator, and differentiate the first. So differentiation of x square plus 1 will become 2x plus 0. Now put a subtract sign and reverse it. So first take this first number and differentiate the second number. So differentiation of x cube will become 3x square. And in the denominator we will write the differentiation of the square of second number. So x cube square. Now we just have to simplify this. So x cube into 2x will become 2x to the power 4 minus x square plus 1 into 3x square. So this will become 3x to the power 4 plus 3x square. Now in the denominator we will write x6. So further on simplifying, it will become 2x to the power 4 minus 3x4 minus 3x square upon x6. This will be our answer. So I hope that all the rules of differentiation are clear to you. Now I am giving you few practice questions based on differentiation. You have to find the differentiation of all these questions and give the answers in comment box of this video. The person who gives all the answers correct, he will be given special appreciation. So I will be looking forward for your answers. I hope you enjoyed the video. Thank you.